building communicates back to it. So everything, whether it's a bigger controller like this, or it's a smaller controller that does an exhaust fan, a VAV damper, it's going to come back and communicate to this. What we do is we then suck out all of the BACnet information. We put alarms, we put histories, we do everything that we need to inside of the Jace. And then once we get all that done, we then push that information up to the front end, and then a graphics set gets built, and then that's what we were looking at before. So this is like the in-between from the front end to the individual buildings. This is the Jace. Here we have the Siemens, it's a TC36. They make two other versions. They make a 16 and a 24. The number just indicates the number of points that each one of them has. So this one is the biggest one that they have, which is the 36. This one here is going to be for the air handler in this case. So it's going to be doing all our air handler control. Up top are all of the outputs, the digital outputs. So just the on and off that we would use, whether that's a fan, a damper actuator, if it's just a two-position opened and closed, a pump, start, stop, anything like that we would do off of a digital output. The bottom section here are going to be all of the inputs, whether that's an analog input like a temperature, or it's a digital input like a status, an on and off. In this case, there's 24 inputs. Actually, excuse me, there's 24 regular, they can pretty much be anything inputs. And then there's a set of here that are just for just straight digital inputs. That's all they can do, is they can tell if something's on or off. Right here in the middle, they have onboard power supplies, so we can use those to power up sensors, power up actuators, whatever we need to do. We can use the onboard power supply here. Up top, this is where the connection is that goes to the building network. So this will get connected into the building network. It then will communicate to the Jace, which is also on the building network. So we kind of build a BACnet IP scheme, and in the Jace we say, okay, I need to look at this IP number right here, so that way I can pull in all of the information from this controller. And then again, we go in, we build out alarms, histories, everything that we need to down in the Jace. Off of the 36, we also have a communication trunk that goes out and connects to all of the BACnet MSDP devices. So the DXRs that are over there in the classrooms, all of those controllers communicate on a BACnet MSDP protocol. We bring those into here, and that's just something else that when we connect to it in the Jace, we say, okay, I need to connect to this controller, one, to bring in all of these points, but then I also need to be able to discover on the MSDP network all of the controllers that are downstream of it and bring in all of those points. So we basically talk to this thing to get the points, but then we also use it kind of as a bridge to communicate to the field level devices. So that's what this is here. And then from here, we have all of our terminal blocks. Up top is our power, and then our commons, and then each one of these lands over on a particular terminal block. And then the numbers here, in this case, we start at number 30, and that connects in right here, and then that's where our field device wires land. So that's where we come in right here. Power supply up top, and then again, just more terminal blocks that the high power or the high voltage comes in. That's really the big thing behind you. Looks like we have another panel. We can look at this one. You can see what's in TC36. So this one, I'm going to guess, is probably doing some kind of miscellaneous control. Again, we have it on the back, the IP network, so we're communicating over IP to now this IP address, and we're communicating back to our Jace. So the Jace is the big brain of the building, I guess you could say, and then these are kind of smaller brains. These are fully programmable controllers, so we can go in here and we can, you know, write a sequence, write a piece of code to, you know, turn on an exhaust fan if a temperature is too high or too low. We can turn on a pump VFD or a pump starter if we need to through some programming based off of, you know, some information that we have. And same thing with the air handlers. We can write a full programming to match the sequence of operations. Got a flow meter and a couple of transmitters. So that is running back to our BTU meter. So we're calculating some information on the chill water coming into this unit. So based off of the temperatures and the flow, this system will calculate that out and give us some energy, or, you know, the energy rating of what this particular unit is doing. So last thing is going to be right here on the wall. That's another differential pressure sensor, but it's for water. So the water lines are hardwired in, and they're coming into the system right there. So we can adjust them. So if these already have ball valves on them, what if they didn't? We could adjust them there, turn them off and on if we needed to.
And the air conditioning and the heater all off the same unit itself.
For this particular unit, yes. Usually what we'll do for the water side, that's going to be more for the actual pumps that are providing water to the whole system. They're going to look at the pressure in the loop, and they're going to say, based off of a set point, they're going to know how high or low to ramp the pump, I should say, up and down to maintain a certain percentage, or excuse me, a certain pressure in the system. So that way we have enough water flowing through the coil to then maintain the temperature set point that the unit needs.
So how does the water tie in with the airflow in the system?
So the way it really ties in is it mainly just makes sure that there's enough water flowing through the coil of the unit to maintain the supply air set point. So it's not really truly like an airflow thing. It's more just making sure there's enough water going through the coil of the unit. So then that way, when we actually do need it, the water flow is there. So because we're going to adjust this thing up and down based off of our supply air set point of say 55 degrees, we're going to adjust this up and down to find 55 degrees. Then we're gonna see it actually just moved. I don't know if you noticed that, but this whole top spun. So that thing's gonna spin up and down to adjust it to meet that set point. So it's not that sensor right there is more than likely not going to be tied back into the air handler. It's probably actually tied in to the controller over there that's doing the logic for the chill water pumps. It's looking at that pressure and saying, you know, my pressure needs to be 10, I'm at 8, I need to increase my pump speed until it gets up to close to 10, then it starts, you know, trying to back off, and it's fluctuating up and down, and it's trying to maintain that 7. Because we figured, you know, somebody's come in and measured it and figured out that 10 psi, or, you know, 10 whatever, 10, 11, 12, whatever it may be, is what this air handler needs to be able to flow water. They kind of work in, you know, they work hand in hand, but usually they're not all on one controller. It could be that controller does have the ability to have expansion modules on it, and we have a lot more inputs and outputs on it. So in theory, you could make one controller do everything, but then you've got one controller doing everything. That one controller goes down, you lose your air handler, you lose your chill water system, you lose all your visibility, just, you know, you're losing everything. If you at least have it broken up into different controllers, one controller goes down, then you're only missing a piece of